So, 7th graders, let's look at lesson 1-7. This term inductive reasoning. What does that involve? Andreas? What does this involve? Inductive reasoning. Okay, what does that mean? Raiden, stop singing. What does that mean, finding an answer based on a pattern?
Like we could get like how much it's adding against the pattern.
Okay, so in a numerical pattern, how are the numbers changing? Okay, comparing the numbers that are next to each other. So how do you compare numbers that are next to each other? What operation would you use to compare numbers that are next to each other in a pattern? Yeah.
We use like a sequence.
Yep. But how would you compare two numbers that are next to each other in a pattern?
You would like add each other, or like add yourself.
If you were looking for a pattern, and the two numbers next to each other, how would you compare them?
I would compare them by the smaller number and see if it adds times up to the bigger number.
Okay, so see how it adds to the bigger number. So to compare them, you'd have to find the what? Difference of them. You have to find the difference of them. How do you find the difference? Rate it.
Subtraction.
Subtract them, yes. So you subtract the numbers next to each other to find their difference, and then use that to look for a pattern. Okay? So when you're looking for patterns, you have to compare the numbers next to each other in a number sequence by subtracting them, and then look for a pattern. And then based on that, you can write what's called a conjecture or a conclusion based on that. Okay? So let's look at the sheet that I handed out. First, so I'll need to it says write a rule. And find the next three numbers in the pattern. So take a look at number 1. How do you compare those numbers? Andreas? They're multiplied by 3, so they're multiples of 3. Good. Yep. They're multiples of 3. So you could use the rule of either add 3 to the previous one. In other words, start at 3 and add 3. Or you could say, what? How could you use multiplication in your rule? Andreas?
You would add 3, on each number, like 3 times 2 is 6, and 3 times 5 is 15. So you multiply 3 times 6 and you get your next answer.
Yes, yep, you multiply the number in the pattern by 3, the multiple of 3. So, 3 times 6 is 18, 3 times 7 is 21, 3 times 8, 24. And then you can write your rule. So, when you're writing a rule, you have to, everybody pay attention to this, you have to tell what number you're starting with when you're writing a rule. Okay? So, if you say you're going to add 3, you have to say, what are you going to add 3 to? Your pattern has to start with a number. In this case, start with 3 and add 3. Start with 3 and add 3. Or multiply the multiple by 3. Or multiply the number in the sequence by 3. So it's the first number times 3, then 2 times 3, and then 3 times 3, and so on. How about the next one? What's the pattern? Liv.
You add it, so again, so like 1 plus 1 equals 2.
Okay.
4 plus 4 equals all that.
Yep. So double the number, or multiply the number times
It's 2.
times 2.
Are
you wait?
So this is what
Okay.
I did. So I did 1 plus 1 equals 2, 2 plus 2 equals 4, 4 plus 4 equals 8, 8 plus 8 was 16, 16 plus 16 equals 32, 32 plus 32 equals 64, and then 64 plus 64.
Okay.
That's what I did.
So start with 1 and add the number to itself. Or you can multiply, you can start with 1 and multiply the number times 2. Okay. So always tell what number you're starting with. Okay? Always tell, in your rule, tell what number you're starting with. Yes? N times 2. N being the number that you're starting with, and multiply it by 2. Okay? Now, what is a counter example? Look at the next section. It says, is the statement correct or incorrect? If it's incorrect, give a counter example, Tyler. What's that? Nate? No ideas? Counter example. Well, what's an example of something? An example is something that reinforces it, right? So a counter example is an explanation or an example that does not reinforce the statement. So, is this true? All roses are red. Is that a correct statement? Right. It's incorrect. It's a false statement. And a counter example, some roses are white. Or pick another color.
Black.
Another black?
They
Wow.
grow in a certain place,
But black's not a color.
but
Black's not a color though.
Still has color in it. Still has color.
it's not a color.
It isn't.
It might be a bird, isn't it?
Well, I pull out my
Oh, it's
frame.
I don't know.
See, and you
This is
say-
Edgar says it's not a color. And
Yes.
It's an absence of color.
It still has color in it.
no, it doesn't, bro. It's
No,
not a
one
color.
is
Well, I'm guessing that the roses are not pure black, but rather a shade of black, which then would include color.
If
Okay.
only roses were like black, red, and white.
So for each of these, give a counter example if the statement is false. Okay. And then finally, look at those geometric patterns, and then draw the next figure. Okay.
Is that what it is? This one.
Any questions?
Yeah.
Yeah.
On what to say for this one. Because I know it says 6
Start
to
at
7.
6.
7 goes to
So you have to write down what number to start with.